Hello and welcome to The Explainer. Today, we're going to tackle something we use every single second of our lives, but honestly, probably don't think about enough. We're talking about energy.
Okay, let's dive right in. Picture your morning. The alarm goes off, you manage to get out of bed, you head to the kitchen, and you pop a slice of bread in the toaster. All of that, the simple act of moving, the heat from the toaster, the little light that tells you it's on, it all needs energy. But where does that energy actually come from? And where does it go?
To really wrap our heads around this, we need to shift how we think about energy. Instead of some vague, invisible force, I want you to imagine it's held in different containers, or what scientists call stores. Each store holds a specific type of energy, just waiting to be used or moved. And here they are, the main players in our energy story. You've got chemical energy, which is locked away in things like food and batteries. There's kinetic energy, that's the energy of pure movement. Thermal, which is just heat energy. And then you have a couple of potential energies. Gravitational, which is energy stored because of an object's height. And elastic, the energy in something stretched, like a rubber band.
So let's go back to that breakfast you're making. That piece of bread, it's a perfect example of a chemical energy store. Your body is this incredible machine designed to break down the chemical bonds inside that food to release the energy it needs to get you moving. It is literally your fuel for the day.
And we can actually measure this fuel in units called kilojoules or kJ. What's fascinating is how much our needs vary. A 10-year-old needs about 8,000 kilojoules a day to run around. But look at an adult male with a physically active job, we're talking about 14,000. That's a huge difference, and it really shows you that the more you do, the more fuel you got to put in the tank.
So you've eaten your toast. Your body gets to work converting that chemical energy. The moment you stand up and start walking around, that energy gets transferred into a different store, the kinetic energy store. It's super simple. If something is moving, it has kinetic energy.
And this is really the most important part. Energy is almost never static. It doesn't just hang out in one of these stores forever. The real magic happens when it moves from one store to another. This is called energy transfer. And believe me, it is happening everywhere, all the time.
So how does it get from A to B? Well, there are four main ways, or pathways, for this transfer to happen. Energy can be moved mechanically, like when a force pushes something. It can be moved electrically, through a current. It can move through heating, which happens when temperatures are different, or it can move by radiation, like light and other waves. Let's go back to our hero, the toaster. It's plugged into the wall, right? The second you push that lever down, you create a path. Energy travels from the power grid through the wires in your wall and into your toaster using that electrical pathway. And this sets off a brilliant little chain reaction. As soon as that electrical energy arrives, it doesn't just sit there. The wires inside the toaster start to glow, and they immediately begin transferring that energy to the bread through the heating pathway. So we've just watched energy go from the electrical pathway right into the bread's thermal energy store. And if you could zoom in, what would you see happening in those glowing wires? Well, it's something called conduction. The electrical energy makes the tiny particles in the wire vibrate like crazy. These jiggling particles then bump into their neighbors, which makes them jiggle, and so on down the line. It's like a microscopic game of dominoes, passing the energy along.
This brings us to probably the single most important rule in all of physics. It's called the principle of conservation of energy. And it says something really simple but profound. You cannot create energy out of thin air, and you can't make it disappear. You can only move it around or change its form. The total amount of energy in a closed system is always the same.
So let's tackle a phrase we all use. You get home after a long day and you say, "Ugh, I've used up all my energy." It feels true, but it's not quite what's happening scientifically. The energy isn't gone. It wasn't destroyed. It's just been transferred or dissipated, mostly as heat, into your surroundings. It's still out there, it's just, well, less useful to you now.
Now, since energy is being transferred, it's pretty useful to know how fast that transfer is happening. And that's where power comes in. Power is just the rate of energy transfer, how much energy moves per second. We measure it in a unit you've definitely heard of, watts. You see this on pretty much every appliance you own. They all have a power rating listed in watts. Now, a higher rating doesn't mean it's a better device.
It just means it's designed to transfer more energy every single second that it's turned on.
So just how much power are we talking about here? Let's look at our toaster again. A pretty typical one can have a power rating of over 1,000 watts. That is a huge amount of energy being transferred every second it's on, which of course is exactly why it can turn a piece of bread into crispy toast so darn fast.
And this is where it all connects back to your wallet. Your electricity bill, they don't actually charge you for power. They charge you for the total energy you transferred. The unit they use is the kilowatt hour. So an appliance with a really high power rating, like our toaster, is going to cost you more to run because it transfers a ton of energy. It's all about power multiplied by time.
So let's wrap this up. We've seen that energy is held in stores. It's moved around through different pathways, and it's always conserved. But we also saw that it often dissipates into forms that aren't very useful. Which leaves us with a final question to chew on. Since energy is never actually destroyed, what do you think is the biggest source of wasted energy in your daily routine? Something to think about. Thanks for joining us for The Explainer.